In this video, we're going to discuss our first topic in differentiation, which is the gradient function as well. We're using these three different formulas: y equals x to the n, and the dy dx of that is nx to the n minus 1. Y is equal to c, where c is a constant. Again, let me put here, your c is a constant, and the derivative of that is equal to 0. Y is equal to cx to the n. The derivative of that is cnx to the n minus 1. So let's try to have our first example. Example number 1 is that if I have my y is equal to x to the 7, by using the formula number 1, this formula number 1 there, it says the derivative of that is nx to the n minus 1. Your n is 7 there. So therefore, the dy dx of that, the dy dx is equal to 7. You put down the 7 in front, x, and then 7 minus 1, which is 6. So this one now is our final answer. Let's try to have example number 2. Suppose my y is equal to 8. So your 8 is a constant, so the derivative of that is equal to 0. Any constant, the derivative is 0. Let's try to have one more example. Suppose you have 8 is equal to 1 half. 1 half is a constant again, so the derivative of that is also equal to 0. Suppose I have number 4 and my y is equal to the square root of 3. This one is a constant, so the derivative of that is equal to 0. So the derivative of any constant is equal to 0. Let's try to have example number 5. Suppose that I have where my y is equal to 6x cubed. So now there's a constant in front, and then we have this expression in terms of x, so therefore the derivative of that, according to the formula number 2, so this, formula number 3, y is equal to cx to the n, is cnx to the n minus 1. So meaning, you just need to copy your 6, your c is 6 there, then put down the 3 times 3, then x raised to 3 minus 1, which is 2. Then just simply simplify that. You have your 18x squared. So that is how you're going to apply formula number 1, 2, and 3. What about if we combine all of these formulas in one question? Let's say, for example, I have number 6. So my y is equal to 3x cubed minus 4x plus 8. Okay? So for you to be able to answer this kind of question, you're going to use the formulas on each term. So you have a y is equal to this, you put in front, 3 times 3 is 9, x raised to 3 minus 1 is 2, minus 4x. So the derivative of 4x is only 4. How come? Because this is raised to 1 there, raised to 1. So negative 4 times 1 is negative 4. Then that is x raised to 1 minus 1 is 0. But remember, any number raised to 0 is 1. And this one now here is 0. So therefore, our final answer is 9x squared minus 4. So you don't need to write this x to the 0 or that 0 there. Alright? So from this question, you can write directly your answer. Let's try to have one more question, number 7. Suppose I have my y is equal to x cubed plus 3x minus 4, and that's all over, let's say, x to the cube. Alright? So in this type of question, what we're going to do is to divide each term first by x cubed, because here you have 3 terms and then here you have 1 term. So what you need to do is to simplify it first. You have your x cubed over x cubed plus 3x over x cubed minus 4 over x cubed. And then after that, you simplify it further. This is equal to 1. This is equal to plus 3 over x squared. And this is minus 4 over x cubed. However, this one can also be written as, let me just write it down here. This is equal to 1. This one, we can write that as 3x to the negative 2. Then this you can write as negative 4x to the negative 3. Then now we can get the dy dx. After you simplify everything, that's the time that you need to get the dy dx. The derivative of 1 is 0 because 1 is a constant. Let's not write that down. Then this one is 3 times negative 2, that's negative 6. X raised to negative 2 minus 1 is negative 3. Then negative 4 times negative 3 is plus 12. X negative 3 minus 1 is negative 4. So that is now our final answer. If you'd like to write this, as negative 6 over x cubed plus 12 over x to the 4th, that's alright. Okay, so that is our final answer for that. Now, one of the application of this derivative is the gradient function. Basically, all of this one here is a gradient function, meaning the derivative of this function is a gradient function. In the next video, I'm going to discuss about this gradient function further. Thank you.